Hey, welcome to the second installment of organic chemistry, specifically naming organic compounds. And for this lesson, we're going to focus on the basic compounds, alkanes, which will form the foundation of how we name all of the compounds moving forward. So of all of the naming part of organic chemistry, this lecture is the most important. You have to have these steps down perfectly. So if you take a look on the screen, I have a slide up that shows the steps that we're going to go through for each compound that we approach. Now, in this lesson, all of the compounds that we're going to be dealing with are alkanes. So if you recall what that means that they're carbon and hydrogen only and carbon-carbon single bonds only. So that means the ending of all of my compounds are going to be ANE. And you can see step one, we're not going to focus on that very much for this lesson, but step one says to identify the functional group, because that's going to determine the ending. So in all of these, we're just telling you right up front, they're all alkanes. That's the functional group. So the ending of all of the root part of our names will be ANE. So that's just something important to remember. So the best way to learn the steps, in my opinion, is to actually go through the process, go through each step. With examples. And we're going to start with basics, and then we'll get more and more complicated as we go along. Okay, so let's start with naming this compound right here. So again, we already know that it's an alkane. So then after step one, once we identify that it's an alkane, okay, so step one, we identify it's an alkane. Okay, we find the longest chain. Well, this is easy. The longest chain is right there, 4 carbons long. There's the longest carbon chain. And again, you can do it a couple different ways. You can circle it or you can put a line through it, but you will need to put a line through it. You need to find the longest continuous chain. In this case, it's 4 carbon atoms. So that means that the prefix will be but. So the root part of my name is going to be butane. So but for 4 carbons, ane for the functional group. Now the next steps have to do with numbering the chain and the substituents, but there aren't any substituents on this compound, so this is going to be the correct name of that compound. Now things get a little bit more complicated when we have branch compounds. So here's a branch compound. So again, following the same steps, we know that it's an alkane. So we know the ending is going to be ANE. Same thing here, we have find the longest chain, 1, 2, 3, 4. Now, in situations where you have a branch, so this is called a branch, it's coming off of a chain. Make sure that you count to make sure that that's not the longest chain. 1, 2, 3, 4. So either way I count in this case, I'm getting a chain of 4. Now, if they're equal chains, no matter how you count, doesn't matter which one you circle, you're going to get the right answer either way. So I'm going to circle my longest chain right there. 4 carbon atoms. 1, 2, 3, 4. Notice I didn't circle that one because that's not part of the same chain. In other words, I can't circle that one and also circle those. So if I would think about drawing a line through without picking up my pen, I would have to go through those. That's a branch coming off of the side. Okay, so we've circled the longest chain and we identify that as 4 carbons. So that's 4 carbons. So again, we know that the root part of our name, the longest chain, is going to be butane. Now, since we have a substituent, we have more steps we have to do. The next step is to number the chain starting from the side closest to the substituent. So you can see here if I start numbering this 1, 2, I hit the substituent 3, 4. That is better than naming it the other way. 1, 2, 3. Because if I started on the right and went this way, it would be on 3. So you always start on the end that's closest to a substituent. 1, 2, 3, 4. So now we numbered the substituent, numbered the chain. Now for the last part, we name and number the substituent. Okay, so the first thing that we do is we look to see what number of carbon is that attached to. That's attached to the second carbon atom in the main chain. So that 2 right there is going to give me a 2. Next, I look to see how many carbon atoms did I circle. I circled one carbon atom. The prefix for one carbon atom, you'll recall, is meth. So it's going to be 2-meth. And if it's a substituent, not part of a main chain, if it's a substituent, the ending isn't ANE, the ending is always YL. So this is going to be called 2-methyl. That's the name of that substituent. Now we write the whole name together, putting the substituents in front of the main long chain, and if there's more than one substituent, we number them, we list them alphabetically. Okay, so just one. So the name of this is going to be 2-methyl butane. And there is no space between there. This is a 2-methyl. No spaces between there either. So in order to get the name right, we have to be correct with our punctuation also, our spelling. So 2-methyl butane, all one word, is the name of this compound. Okay, moving on to another example. Now, again, step one, identify the longest chain. Well, sorry, step one, we know it's an alkane. We got that down. Okay, so now we look to identify the longest chain. 1, 2, 3, 4, 5. So you might be tempted to say, oh, look, there's the longest chain. But remember, when we're saying straight chain, we just mean continuous chain. So we need to check for other possibilities. 1, 2, 3, 4. If I go up here, 5, 6. That's a longer chain than if I went just straight across. So my longest chain isn't straight across. My longest chain is actually going like this. There's my longest chain. So you have to be careful. Check every possibility. 1, 2, 3, 4, 5, 6 carbons is longer than if I just circled this chain going straight across. That would only be 5 carbons. So that is my longest chain, 6 carbons. And so that 6 carbon prefix is hex. So the root of this is going to be hexane. That's going to be the main part of the word based on the longest chain. The next thing we look at is the substituent. And in order to do the substituent, we have to number the chain. Now, we start from the side that's closest to a substituent. 1, 2, 3. I hit the substituent there, as opposed to 1, 2, 3, 4. So now I'm going to start numbering it from this side. Number the main chain. 1, 2, 3, 4, 5, 6. So there I've numbered my 6 carbon chain. Now I circle this, that's my substituent. It's on the 3rd carbon, so it's going to be 3, because it's on the 3rd carbon. It's a 1 carbon chain, substituent here, that's 1 carbon, so again that's meth. But since it's a substituent, I'll call it methyl. So the name of this compound, when I put it all together, is going to be 3-methyl hexane. 3-methyl hexane is the name of that compound. Okay. Next one we're going to look at right here. So again, finding the longest chain is the first step. 1, 2, 3, 4, 5, 6 across there. 1, 2, 3, 4, 5, 6 up there. So 6, no matter how I do it, I guess we could go around in a circle here. 1, 2, 3, 4, 5. That way smaller. So 6. 6 going straight across or 6 going over and jogging up. Doesn't matter which one we circle. We'll get the same answer either way. So I always prefer to just circle the straight one across. So there's our longest chain. Again, 6 carbon atoms, so that's going to be called hexane. Now we number 1, 2, 3 gets me to a substituent versus 1, 2, 3, 4. So I'm going to number from the right side. 1, 2, 3, 4, 5, 6. Now I circle my substituents. That's a substituent. I can circle the whole thing in one circle, so I'm going to circle the whole thing. So this is on the 3rd position, 3rd carbon atom off the main chain. And now this substituent has 2 carbon atoms. 2 carbon atoms. 2 prefix is F, ETH. So this will be ethyl substituent. So when I put this all together into a name, it's going to be 3-ethylhexane. 3-ethylhexane will be the name of that compound. Okay, so by going stepwise, taking your time, hitting each of the steps will really help, especially when things get more complicated. Okay, so now let's take a look at this one. Again, another more complicated molecule. Longest chain is going to be straight across, and you should double check that, but there's the longest chain. 1, 2, 3, 4, 5, 6, 7 chains. 7 carbon atoms is hept. H-E-P-T is 7 carbons, and this is an alkane, so it's heptane. Now we're going to number. Obviously, we're going to start from the left this time because it's closer to the substituents. 1, 2, 3, 4, 5, 6, 7. Okay. Now I circle that substituent. That substituent is going to be 2-methyl. Because there's 1 carbon in there. It's on the 2nd position. On the 3rd position, right here, I have a 2-carbon chain. That's F, so we'll call it ethyl. So now I've named my 2 substituents and my main chain. Now we put it all together. And for the last step, you just have to remember to list the substituents alphabetically. So now we have a choice. We've got ethyl and methyl. We just focus on the letter there. E comes before M. So the name of this compound is going to be 3-ethyl. Then you have a dash, 2-methyl heptane. Sorry, I missed the L here on this methyl. There we go, methyl. So the full name, 3-ethyl 2-methyl heptane. Okay, again, no spaces in here at all. After a number is a dash and before a number is a dash. So 3-ethyl 2-methyl heptane is the correct way to name this. Okay, we're going to work a few more just to get a couple more points down on more difficult compounds, a couple tricks that you're going to need to be aware of. Here's our compound, again, following our procedure, longest straight chain. It's going to be right there. Again, double check that, but you'll find that that's going to be the longest chain. We're going to number the chain, 1, 2, 3, 4, 5. So this is going to be pentane, because 5 gives us the pent and ane for an alkane. Okay. Now we have our substituents. There's a 2-methyl. See, that's a 2-methyl group here, and here we have a 3-methyl. So they're both methyl groups because they have 1 carbon. The first one's off the 2nd carbon. The second one is off the 3rd carbon. Now here's where the subpoint comes down on our list, on our procedure. If you have identical substituents, you can combine them. Okay, and you should combine them. So first of all, I'm going to put it together the full way, the way that we've learned so far. So what I can say is I can say 2-methyl 3-methyl pentane. Now, I would know that's the right name for this compound, but technically it's not going to be correct because we can shorten this up by combining these 2 groups. Since I have 2 methyl groups here, I'm going to combine them and say I have dimethyl. So di meaning 2. But because I'm still naming 2 of them, I have to have the numbers for each of these. So what I'm going to do is I'm going to combine them by saying 2, 3 dash dimethyl pentane. And that's going to actually be the correct name for this compound. So di here doesn't mean 2 carbon atoms. Di here means I have 2 methyl groups. And because the di here means I have 2 methyl groups, I still have to say what numbers they're on. They're on the 2nd and 3rd carbon positions. So if I see a di here, there has to be 2 numbers in front. This could go further up here too. If this was a tri, that would be fine. If there were 3 methyl groups on this compound, then I would need 3 numbers in front of here. So that's what we mean when we say we combine the substituents. Okay, let's look at another example. Again, getting about as complicated as we're going to get here. Okay. Longest chain is going to be straight across. There's our longest chain. We're going to number it from the side closest to the substituent. So I'm going to number it here. 1, 2, 3, 4, 5, 6, 7. So 7 is hept. So heptane is going to be the root of this word, the longest chain. Now I name and number all of the substituents. Now pay close attention. This one is going to be a 2-methyl. This one is 3-methyl, but this one is also on the third carbon and a methyl, 3-methyl. So both of those are going to be called 3-methyl. This group, I can circle both of those together, so that's going to be a 4-ethyl. So now I have everything here named. Now I just got to put it all together. So I'm going to name ethyl first because that comes before methyl. So we focus on the name of the actual substituent. But I'm going to combine these 3 methyl groups that are all identical into one, and I'm going to call that trimethyl. Okay. So I'm going to have 4-ethyl because that comes first alphabetically. Then I'm going to name all 3 of these numbers. 2, 3, 3. 2, 3, 3. That's where I'm getting those from. Dash trimethyl heptane. Okay, so see 3 numbers here. Tri, it doesn't mean that it's a 3-carbon chain. That would be prop. Tri means that there are 3 methyls. There's a methyl on this 2, the 3, and the 3. So make sure you keep in mind that we have to have, even though they're both on the 3rd carbon, I still have to indicate that they're both on the 3rd carbon. Without that other 3 there, I wouldn't know where that 3rd methyl group was. So very important. Okay. Our last example, just to reinforce, again, finding the longest chain. Once we get all the rules, don't forget the longest chain doesn't have to be straight across. In this case, you'll see it actually jogs down. That's going to be my longest chain. And now when I number, I'm going to start numbering from the left. 1, 2, 3, 4, 5, 6. Okay, so 6 is hexane. So we did that. Now we number the groups. This is a 3-methyl. And this is, I'm sorry, that was a 2-methyl. 2-methyl. And this one is a 3-methyl. So make sure you're always circling and labeling everything, finding that longest chain. Now again, we put them together into a single name. It's going to be 2, 3 dimethyl hexane. Okay, so di meaning 2 methyls, and I need numbers for both of them, so I have the 2 and the 3. All right, so that's our first lesson on naming basic alkanes. We're going to follow this up with more complicated examples. We're going to add on functional groups. And one thing I haven't done yet is taken the name and go backwards into the formula, something that we'll also have to be able to do. All right, see you next time.